When we think of planets, we often imagine worlds somewhat like our own, perhaps slightly hotter or colder, with varying landscapes but generally familiar. However, the universe is far more diverse and strange than our earthbound experiences can fully grasp. Among the thousands of exoplanets discovered so far, there are some truly bizarre worlds that defy our expectations and challenge our understanding of what a planet can be. Let's embark on a journey to explore these otherworldly realms, where the night never ends, the winds shred everything in their path, and the very atmosphere is a deadly cocktail of burning gases. Our journey begins with Trace 2b, a gas giant that orbits a star located about 750 light-years from Earth in the constellation Draco. This planet is an enigma, shrouded in perpetual darkness. Unlike the serene night skies we are accustomed to, Trace 2b is a place where night is not just the absence of sunlight, it is a pitch-black void. This gas giant is so dark that it reflects less than 1% of the light that hits it, making it one of the darkest known planets in existence. But the darkness of Trace 2b is not its only strange feature. The planet is incredibly hot, with temperatures soaring as high as 1,800 degrees Fahrenheit, 980 degrees Celsius. The air on Trace 2b is scorching and might even glow faintly red due to the intense heat, giving it an eerie, otherworldly appearance. Scientists believe the planet's atmosphere contains light-absorbing chemicals, possibly vaporized sodium or potassium, which contribute to its extreme darkness. Trace 2b challenges our perception of what a planet should be, offering a glimpse into the truly alien environments that exist in the universe. Moving closer to home, at a distance of about 41 light-years from Earth, we find 55 Cancri e, a planet that could easily be mistaken for a vision of hell. This exoplanet orbits its star so closely that a year there lasts just 18 hours. The planet is tidally locked, meaning one side perpetually faces the star, while the other remains in eternal darkness. On the day side of 55 Cancri e, the temperature soars to an unimaginable 4,400 degrees Fahrenheit, 2,427 degrees Celsius, hot enough to melt iron. The intense heat creates an ocean of molten lava that covers much of the surface, boiling and bubbling in the relentless glare of its star. On the night side, however, the temperature is much cooler, though still far too hot for any known form of life. Between these two extremes lies a twilight zone, a narrow strip where temperatures are relatively more moderate but still far from hospitable. The stark contrasts on 55 Cancri e make it one of the most extreme and inhospitable places known to us. It's a world where fire and darkness coexist in a fragile balance, creating a landscape that is both fascinating and terrifying. Next, we travel to HD 189733b, an exoplanet that might look beautiful from a distance, with its blue and white swirls resembling Earth's clouds and oceans. But up close, this planet reveals a far more sinister nature. HD 189733b is located about 64 light-years away in the constellation Vulpecula and is the closest hot Jupiter to Earth that we can study. The vivid blue color of HD 189733b is not due to water, but rather to high clouds laced with silicate particles. These particles scatter blue light, giving the planet its striking appearance. However, the beauty of HD 189733b is deceptive. The same silicate particles that create its blue hue also lead to one of the most terrifying weather patterns imaginable: glass rain. On HD 189733b, temperatures reach around 1,700 degrees Fahrenheit, 927 degrees Celsius, and winds blow at speeds of up to 5,400 miles per hour, 8,690 kilometers per hour, nearly 7 times the speed of sound. These winds carry tiny shards of glass, which rain down sideways due to the planet's intense weather patterns. The combination of hypersonic winds and razor-sharp glass particles would make survival on this planet impossible for any form of life as we know it. In another corner of the galaxy, we find a system where planets are slowly being destroyed by their own star. This system is centered around a pulsar, a rapidly spinning neutron star, the remnant of a supernova explosion. Pulsars emit powerful beams of electromagnetic radiation, which sweep across space like lighthouse beams. The planets in this system, whose names are too complex to easily remember, are being gradually eroded by the intense radiation and gravitational forces of the pulsar. These planets are bombarded with deadly pulses of energy as the pulsar spins thousands of times per second. Over time, the planets are being stripped away, layer by layer, until nothing remains. This slow destruction offers a stark reminder of the violent forces at work in the universe. It also raises questions about the origins of these planets. How did they come to exist in such a hostile environment? And how long will they survive before being completely annihilated? One of the most extraordinary stories of planetary survival can be found in the Kepler-70 system. Kepler-70b, a planet that once orbited a star much like our Sun, managed to survive the death throes of its parent star. About 18 million years ago, the star expanded into a red giant, engulfing the planet in its outer layers. Remarkably, Kepler-70b was not destroyed but transformed into a blazing hot, rocky world. Today, Kepler-70b is one of the hottest known planets, with surface temperatures exceeding those of our Sun. The intense heat is slowly evaporating the planet, which now exists in a precarious state, gradually losing mass as it orbits its dying star. The story of Kepler-70b is a testament to the resilience of planets, but also a reminder of the harsh realities of stellar evolution. WASP-12b is another planet facing a grim fate. Located about 870 light-years away in the constellation Auriga, this gas giant is being slowly devoured by its parent star. The gravitational forces between the planet and the star are so intense that WASP-12b has been stretched into an egg shape, with its atmosphere being pulled away by the star's gravity. WASP-12b is losing mass at an alarming rate, and within the next 10 million years, it will likely be completely consumed by its star. This process has turned WASP-12b into one of the most distorted and doomed planets known to us. It serves as a stark reminder of the impermanence of planetary systems and the inevitable destruction that awaits some of these distant worlds. In a twist on the traditional concept of a planet covered in ice, Gliese 436b offers a bizarre contradiction. This Neptune-sized exoplanet, located about 30 light-years away in the constellation Leo, is extremely close to its star, with surface temperatures reaching 822 degrees Fahrenheit, 439 degrees Celsius. Despite the intense heat, Gliese 436b is covered in a layer of ice that burns incessantly. The ice on Gliese 436b is not like the ice we know on Earth. It is much denser, due to the planet's enormous gravity, and remains solid even under extreme heat. This hot ice is a form of water that exists only under conditions of high pressure and temperature, and it creates a surreal environment where ice burns without melting. The exoplanets we have explored here represent just a fraction of the strange and wondrous worlds that exist in our universe. From planets shrouded in eternal darkness to those being slowly devoured by their stars, the diversity of these distant worlds is a testament to the infinite possibilities of the cosmos. As we continue to discover and study these exoplanets, we are constantly reminded of how little we know about the universe beyond our solar system. Each new discovery challenges our understanding and expands our horizons, revealing that the universe is far stranger and more complex than we could have ever imagined. The search for exoplanets is not just about finding new worlds. It is about understanding our place in the cosmos and the forces that shape the universe.